Select the statement that best describes the graphs of the lines 15x plus 21y equals 7 and 35y plus 14 equals negative 25x. And these statements that we're to select from deal with whether the lines are parallel, the same, whether they are perpendicular, whether they intersect or not perpendicular. So the best thing to do to start this problem would be to write each of these equations in slope-intercept form, in the form y equals mx plus b. And to do that, we will solve each equation for y. The first equation, 15x plus 21y equals 7, I'll begin by subtracting 15 on both sides, by subtracting 15x on both sides. And then I will divide on both sides by 21, which is the same as multiplying both sides by 1 over 21. And when I use the distributive law here, I get y equals negative 15 over 21x plus 7 over 21. And I can simplify each of these fractions. Negative 15 over 21 is negative 5/7. And 7 over 21 is 1/3. So this equation is equivalent to y equals negative 5/7 x plus 1/3. Now let's solve the second equation for y. I'm going to subtract 14 on both sides first. So I'll have 35y equals negative 25x minus 14. And now I'm going to divide both sides by 35 or multiply both sides by 1 over 35. And using the distributive law, I have negative 25 over 35x minus 14 over 35. And I can simplify both of these fractions. Negative 25 over 35 is negative 5/7. And negative 14 over 35 is negative 2/5. We're subtracting 2/5. So I have both of these equations in the form y equals mx plus b. I can see that each of them has a slope of negative 5/7. So if their y-intercepts are different, they're parallel. If their y-intercepts are the same, they're the same line. And we see that the y-intercept for this line is 0, 1/3. And for this line, it's 0, negative 2/5. So the lines have the same slope and different y-intercepts. That tells me that they're parallel. And we look back over here and we see that statement A says the lines are parallel. So that is the statement that best describes those two lines.